This app demonstrates how to use theoretical distributions. You know from statistical course that any theoretical distribution can be represented by three functions. These functions have these acronyms as PDF, CDF, and inverse CDF. PDF is probability density function. It shows you the shape of your distribution, or in other words, it shows you where the values are mostly expectable. For example, what you see here, it's a normal distribution for height values. Then you can see that this is the point where the highest density. So it means that most of the values are expected to be here. And then the more far you go from this center, the less and less likely, the less and less dense the points are. So it means that the probability to get these points is smaller. Now look, what you see here, it's an area which gives me a chance to get a value smaller than this one. And then you can see this one, it's 170. And 170, it's exactly the average value of in my case, in this case, you can see that. So it means that average value in normal distribution is also a median. So it gives you a border between 50% of largest values and 50% of smallest values, right? Now you can change the value. And then you can see that the average value is still the same. And then you can see that, for example, if you take a height of 160, so you can see that only approximately 15.9% of the values are smaller than 160 in this theoretical distribution. Or in other words, we can say that the probability, if we take a random person from this population described by this distribution, the probability that height of this person will be smaller than 160 centimeters is approximately 0.159. Okay, so you have approximately 16% chance to find such a person, right? And then likewise, if you go a little bit above, for example, 180 centimeters, right? So you can see that this probability is approximately 0.841. So it's 84.1% chance to get a person whose height is below 180, or you can think about the other way around, right? So approximately 16% chance to get a person whose height is above 180 in this population described by this distribution, right? Now you can see that the standard deviation is 10. And we know that plus minus 1 standard deviation gives you approximately 68% of the values in normal distribution. And this is exactly what we see here, right? So we have average plus 1 standard deviation in this case. So 180, it's average plus 1 standard deviation. So if if it gives you 68% of the values in between, it means that you need to have 16 here and 16 here, and you have exactly 16 here, right? Now, what is area on the PDF? Is a y-value on the CDF. So CDF, it's called cumulative distribution function. So you can see that what we have as an area here, we have as a value here. So it's like percentiles that we used in the previous apps, but now we are talking about theoretical percentiles. So that's why we call them probabilities, because percentiles is usually it's a empirical value. So it's what you observe in your observations. And when we talk about theoretical value, the expected value, we use the word probability instead, right? So you can see that again, if you start changing the values, you can see that we change these percentiles, or we change the probabilities, right? So you can see again, if I take 170, you can see approximately 170 here. And then you can see it's 50% or 0.5% probability. And then you can see this is exactly in the middle of the curve. Okay. The inverse CDF function allows you to do the other thing. So you define a probability, and then you will get a value. For example, if I want to find the third quartile for this distribution, what's the value corresponding to the third quartile? What's the value corresponding to 75th percentile? I can set the probabilities to 75. Let me see if I can do it. So this is 75. And this is the value, right? So this is the third quartile, 176.7 centimeters. So it means that approximately 75% of people in this population have a height smaller than this one, and then 25 have heights larger than this one. And likewise, I can also compute the first quartile. So I need to set the probability to 25, and then the ICDF function, let me try this one. And then the ICDF function will tell me the value for the first quartile. So it's a bit difficult here, but it's approximately this one, right? You can also use these functions in interval mode. So if you click interval here or here, let me just do it like this. So now you can define an interval. So for example, let's define interval between the first and the third quartile. So this will be the third quartile. this one. And this I will set to the first quartile, 25%. Now you can see this is the interval, right, between the first quartile and third quartile. And this is exactly the interquartile range. So this is the interval in centimeters. And look, the area is approximately 50%. Why it's not exactly 50%? Because of the rounding. So this is not exactly 25%. This is, I have some rounding error, so to speak. So that's why you have not exactly 50% here, right? Likewise, for example, you can set a value to 2.5 here, 2.5% here, like this, and then 97.5% here, like this. And then you can see how many values we have in between. We have 95% of the values, right? But now look at the values, right? Look, what is 189.6? It's 196 standard deviations larger than the mean. What is 150.4? It's 196 standard deviations smaller than the mean. That's exactly this rule, right? So in normal distribution, if you want to get 95% of most common values, you should go by 196 standard deviations from the mean to both directions. And that's what you also see here, right? So this is exactly the 95% of the most common values, okay? So this is how it works. I recommend you to play a little bit with the standard deviation, with mean, and see how this influences actually the shape of the distribution. And also you can also do this for the uniform distribution. So it's a bit simpler. Uniform distribution looks like a rectangle, so the density function looks like a rectangle, and then the CDF and ICDF looks like just a straight line. And then you can also play a little bit with all these intervals and the probabilities using the uniform distribution. So I recommend you to play with this, and then hopefully it will make your understanding of these three functions a little bit better.